Hi students, in this video we are going to see about the normalization and its types. In the previous session we have seen what is functional dependency and what is data redundancy and why we are going for the normalization. So what is a functional dependency? A functional dependency is a relationship between two attributes in a relation. So a functional dependency, it does not exist in all the relations. That is, if two attributes are said to be in functional dependency, one attribute uniquely determines the other attribute. Then only a functional dependency is said to occur. So there are different types like trivial, non-trivial functional dependency, full functional dependency, partial functional dependency, multi-valued functional dependency. Then we have seen about data redundancy. Data redundancy means in some situation we are supposed to store the data multiple times in the same table. So because of this it creates more space in the memory. So we have to find some solution for this data redundancy because it may result in many problems like insertion anomaly, deletion anomaly and updation anomaly. For example, if you are trying to insert redundant data, then definitely it will increase the size of the database. And second thing, if you try to remove a data where the related data is also present in the same table, that is, the related information does not have any backup in the other tables. So in that case, if you try to remove the data, then along with the data, the related data set is also deleted. So this will result in deletion anomaly. In updation anomaly, you are supposed to update a particular column value, and if you fail to do that for one single record, then that particular record will be obsolete because of this mistakes. So in order to avoid all these data redundancy, we are going for normalization. So normalization is a process of organizing the data in related tables. That is, by reducing the data redundancy, we can store the data. So normalization, it will not remove the redundancy completely, but it helps in minimizing the redundancy. So these are all the concepts which we have seen in the previous class. So let's come into the today's topic. Today's topic is we are going to see again what is normalization and what are all the types of normalization. In the previous class, we have seen about first normal form. So here we will see an introduction about the first normal form and then we will see what is the second, third and next upcoming normal forms. So let us go into the topic. What is normalization? It is an organizing the data in the database, minimizing the redundancy from a relation or a set of relations, eliminate the undesirable characteristics like insertion, update and deletion anomalies, and it divides a larger table into smaller related table, that is smaller tables which are linked with the relationship. So this is what normalization is. Now there are different types of normal forms like first normal form, second normal form, third normal form, BCNF, fourth normal form and fifth normal form. But we are concerned only till boys code normal form, that is BCNF. Fourth normal form and fifth normal form you may study in the advanced version of the database management system. First normal form. So a table is said to be in first normal form. It has to satisfy certain condition. Like first thing, all the values in the table must be atomic. That is, no multiple entries of data should be there. Second is, the values of a particular column should be of same type. Third one is, all the columns should have unique name, because if there is any duplication in the column name, it will result in a confusion while retrieving the data. And the data, it may be in any order. By using the SQL queries, we can easily retrieve the data which we want. Already we have seen example for the first normal form in the previous video. So let us start with the second normal form. Now how to achieve a second normal form? A table should be already in the first normal form, that is the basic condition. And second thing is that a table should not have any partial dependencies. So, what do you mean by partial dependency? First, let us understand what is partial dependency and then we will try to bring up a solution for that. Consider a student table with 5 columns like student ID, name, register number, branch and address. So, in this table, the student ID is the primary key. That is the attribute which uniquely determines the other attributes in the relation. Now, you can see there are 2 entries similar in the name column, name attribute. In that particular case, if I want to retrieve any data related to Anil, so I may be confused which record I want to retrieve. But if I have the student ID in my hand, I can easily retrieve whether Anil belongs to roll number 1 or Anil belongs to roll number 2. Yes, so as the student ID in this table will be unique, it can be used to easily retrieve the data. Now consider another table called subject table and third table called score table. So you can notice in this table there are 3 attributes with the ID information: score ID, student ID, subject ID. But we may think score ID is the primary key of this table. But the student ID and subject ID together, it will make more meaningful primary key. Let us see how it is. Now suppose we want to find marks of a student. Now I have the student ID with me. So if only with the student ID, if I want to retrieve the marks means, then it will ask me for which subject this marks belongs to. Okay. Now the second case, I have the subject ID with me. Now I am going to get the marks. It will ask me for which student this subject has this marks. So what I am coming to say is both student ID and subject ID can uniquely identify any row of data in the score table. So it has a many-to-many relationship, like a student can opt for more than one subject or one subject can be opted by more than one student. Both can be considered. Now consider the score table. So in the score table, there is one attribute called teacher. This teacher attribute, it belongs to the subject ID only. How? So if I type the subject ID is CS101, then I will find that Mr. Java, Mr. J is the professor. And if I type the subject ID as CS103, then I find Mr. C++ is the professor for that subject. So always the teacher attribute will be dependent on the subject attribute but not the student attribute. But in this case, primary key is a combination of 2 columns, that is student ID plus subject ID, that is a composite key is used as a primary key. In that particular case, when my teacher only belongs to the subject ID and not with the student ID means, this is, we call it as a partial dependency. So partial dependency means what? If a non-prime attribute, it depends on one of the primary attribute in a composite key, means then such case we call it as partial dependency. Now the problem is in our second normal form we should not have any partial dependencies. So how to eliminate partial dependency from this table? Our objective is to remove the teacher attribute from the score table like this. So when I remove the teacher attribute from the score table and place it in the subject table, it makes more sense here, right? And another alternative is we can create a teachers table with the teacher ID and teacher. This also makes more sense. So this is how partial dependency is removed from the table and the table achieves the second normal form. Now coming to the third normal form, if a table want to be in third normal form, the table should be already in the second normal form, and second is there should not be any transitive dependencies. Let us see what is transitive dependency with an example. Now in the score table I am going to add 2 more attributes like exam name and total marks like this. So exam name and total marks are the 2 new columns, and already we know that primary key for the score table is a composite key, that is a combination of both student ID and subject ID. Now, the new attribute exam name, it depends on the primary key of the score table, that is it depends on both student ID and as well as subject ID. How? For example, a mechanical student will have an exam on the workshop, but an IT student won't. So here the exam name, it depends on the student. Now consider another example. For Java program or any programming paper, we have practical exam. But for engineering mathematics, do we have any practical exam? No. So here exam name depends on the subject ID. So is it clear? So exam depends on both student and as well as subject. But what about the second new column, total marks? Does it depend on the primary key of the score table? No. The total marks, it depends on the attribute called exam name. How? See, we have marks split up for practicals, like practicals are of 30 to 40 marks, main exams are of 60 to 70 marks, sessionals are of 40 to 50 marks. So from these example, it is clear that the total marks are completely dependent on the exam name. So here you can see student ID and subject ID are primary key, and the total marks, it is a non-prime attribute. It depends on another non-prime attribute called exam name. That is, it depends on exam name, and exam name is not a primary key. So this condition we call it as transitive dependency. Meaning is that a non-prime attribute is derived from another non-prime attribute, means then such dependency is called transitive dependency. Now, how to eliminate the transitive dependency in this case? What is the solution? The solution is that if we take these two attributes and form a separate table, exam table, then we will achieve the third normal form like this. So we have a student table, we have subject table, and from the score table, I have removed the exam name and total marks and placed it in the exam table. So this is how my table achieves third normal form. Now the next normal form is called Boyce Codd normal form. So this normal form is also called as 3.5 normal form. It is an extension of the third normal form. So for the table to be in Boyce Codd normal form, the table should be in third normal form, and second is that if suppose a relation exists like A derives B, A should be the super key. That is, if A tends to B means A is a non-prime attribute and B is a prime attribute. Till now we have seen that one non-prime attribute only is derived from a prime attribute or another non-prime attribute. But if one prime attribute is derived from a non-prime attribute, then that is not a good design. So that is said to be that not in BCNF, Boyce Codd normal form. So in general, based on our understanding, we know if a non-prime attribute is derived from a prime attribute, such dependency is called functional dependency. If a non-prime attribute is derived from a part of the primary key, means such dependency is called partial dependency. And if a non-prime attribute is derived from another non-prime attribute, it is called transitive dependency. But if a prime attribute is derived from a non-prime attribute, is it possible? No, so it is not said to be in Boyce Codd normal form. Now let us understand all these concepts with the one example. Now take the relation called college enrollment table. So we have three attributes over here. First let us see how many normal forms this table satisfies. First one is, let us consider the first normal form. Now you can see the student ID, subject and professor. So this relation has three columns and all the three columns have unique name. So one condition is satisfied. Second case, see all the column values of each attribute, they have belong to the same type. Yes, so professor means the professor details are there. That is, there is no mix of data type in this particular table. So second condition is satisfied. Third condition is, that is, the table contain atomic values. Each column and each row has only one entry. So we can say this table is in the first normal form. Now consider this example. So I have two IDs, student ID and subject. So together it is used to determine the professor detail. So I can say there is no partial dependency in this table. So it is already in first normal form, and no partial dependency means it is in second normal form. And also there is no non-attribute which is derived from another non-attribute. There is only one non-attribute and two prime attributes. Yes. So here the non-prime attributes, it is derived from the prime attribute only. So there is no transitive dependency. So it is said to be in third normal form. Now coming to the last state, it is already in third normal form, but see the situation here. So professor, from the professor we can also derive the subject. So here student ID and subject are candidate key. Professor is a non-prime attribute, whereas subject is a prime attribute. Yes. Now if a professor can find a subject and a professor is not a super key means it is not in BCNF. So how to find a solution for this? Just by decomposing the table into two relations. College enrollment table will be divided into student table and professor table. So like this. So we got the solution ultimately, and now our table satisfies BCNF. Hope you understood the types of normalization. So coming to the conclusion part, in today's class we have seen what is normalization and the types of normalization. So to summarize, we can say if a table is said to be in first normal form, the value should be atomic and the column's name must be unique. If a table is said to be in second normal form, first thing it should be in first normal form and there should be no partial dependencies. If a table is said to be in third normal form, it should be already in second normal form and no transitive dependencies should occur. And if a table is said to be in Boyce code normal form, it should already in third normal form and non-prime attributes should not derive prime attributes. So hope you got a good understanding of what is normalization. Thank you.